Hi guys, this will be an interesting one. So I hope that you are good. This is the last part of lecture number 4, and I will be discussing about the other part of the HTTP and the web. Right. So remember the previous time we were having a client and a server, and if I can remember that the HTTP is stateless. So when you open a page and you close it, you can't keep the states of the interaction you had with the server. So what you usually do, you have a request that goes to the server, and then the server basically records an entry to the database. And after that, the server replies to you with a response, and it has something we call a cookie. And remember, a cookie is something that helps the HTTP to have a state, right? And it gives you an ID. It's like this is ID number 1678 for the Amazon website. And after that, there is basically an interaction between you and the server, right? And as you go into the website, you're having some sort of cookies happening. Like you have a cookie interaction with the server that helps the server recognizes who is this particular user who's trying to interact with me. So that's basically that. And for this instance, like you'll be having a different interaction between your browser and the server that recognize you as basically cookie number 1678. That's what that thing is there for. So the cookie, it's a little file that will help the server to recognize you and to recognize your interaction with the page, for instance. So when you open your Facebook page, when you open your Netflix page, your Instagram page, then when you come back the next time, you know that you are user 1678. We now know that you are this particular user, and you were running for that particular session, and that is available for the whole time you're running. So it means that for that particular session you have this particular cookie. That's the reason why on Facebook, when you look at the side note on the other side, you would see that you're browsing for Facebook pages and all of those stuff, but Facebook has the information about you looking for shoes, you looking for watches, you looking for assignments and stuff like that. So that's basically how they do. So what I was saying in the previous slide, it was mainly about you being authorized when you're getting into Facebook, and if you're coming back the second time, then it picks up from the previous information that you provided it. And remember, when you're going to do some shopping online and then go back to Facebook, everything is logged into this cookie, so they know exactly what you were dealing with when you were doing those research. Same for recommendation. That's the reason why when you go to some websites, they want you to accept that you'll be having some cookies recording your application, recording your browsing. By law, they need now to tell you that they will record your interaction with the website. That's the reason why there are some uh, little privacy issues when it comes to the cookies, and I would invite you to go and check what we call the GDPR. That's an European uh, equivalent to the Poppy Act. I mean, it's slightly equivalent, but then it will be a nice thing for you to go and read about data privacy. All right. So we're done with the cookies, and you can ask question about that in the discussion forum or bring new stuff. We'll be now speaking about what we call web caches or cache, yeah, web cache or caches. So what we usually do, right? For instance, you have a client. The client is you, right? And then you want to access a website. This is the origin server. So if you want to access that website, then so be it. you access the particular website, www.google.com, and those Google websites are usually located somewhere in the United States. But what if it is too far, like it is from South Africa to the United States, crossing all those cables? That's a lot, right? You wouldn't want to use all of that energy with your internet to get to that website. So usually what happens, you would want to use what we call a proxy server, and the proxy server will be basically helping you with the transaction here between you and the particular server, right? So it would say, uh, make use of this particular guy to access the origin server. So what you will do, you want to access Google. Let's say google.com. And google.com is somewhere in the US, the United States. So for us to stop this, to say, okay, cool, we have some sort of proxy server or some sort of cache in the middle that would say, okay, copy everything that, I mean, whatever the user wants, store it here, right? And then if the user wants the page, then he hits here and then gets the response here. It is it is quicker for the user to have a response from the proxy server, but the proxy server always still has to speak to the original server. So that's the main use of those caches or the proxy server. That's basically how they work, right? So if the object is in the cache, then return that to the user. If it's not in the cache, then go and fetch it and return it to the user and keep it just in case. It means that if me now I want to access Google as well, right? And then this Google page is already stored in here. I'll hit here, and the proxy server will send me back the response, as as we basically see here. So I'm making the request to the proxy server, and then I have a response from the proxy server, and I have that page. That's basically how it works, right? Now, these are the basically the use cases of the uh, caches, and you would see that it reduces the response time of the client request, obviously. So if maybe they take that an example. There is an information in Pretoria, you're in Johannesburg, and if the information can get held somewhere in Midrand, so you won't have to travel to Pretoria to get the information. You go to Midrand and get the information, as same as you went in Pretoria. It reduces the traffic, right? So we don't have to all go to Google there to crash Google. We'll go to a proxy server. If there's a problem with the proxy server, then we change to proxy server, right? So, and it's typically, and this is a very important one, is typically cached by the internet service provider. And we will have an example about that in the next slides. And I'll do a live demo for you. That instead of going to Google, right, or to Microsoft Bing, we go to the internet service provider instead to get that page, since a lot of people want that page. But before going to the live scenario, let's go to the little calculations of how these things work. A little scenario here. Let's assume that we have an access link rate of 1.57 megabit per second. This is the internet cable that links you or your organization to the main internet, right? So this link is 1.57, 1.54 megabit per second. The round trip time, or RTT, right? This is the round trip time between this point and that point. Is basically 2 seconds. In most of the calculations, some people would use 2.01 seconds, right? To be precise, the internet delay between your, let's say, your institution or yourself and the internet is 2.1 seconds. You can go and Google that. The object size is 100 kilobyte per second, kilobit per second. But what I'll do, I'll literally convert that to megabit per second. Sorry, megabits. Right, that's it. And the average request rate from the browser to the origin server is 15 per second, or it's 15 requests per second. The average request rate from the browser to the origin is 15 requests per second. What does that mean? Like in average for an object of zero point 0.1 megabit per second, then we make 15 of those requests to the server, right, to get the response. Means that the average data rate to the browser, the average data rate to the browser is basically the number of requests multiplied by the number of multiplied by the size of the object. Remember, the number of requests, like the number of requests multiplied by the size of the object, which is the number of requests here is 15 multiplied by the size of the object here 0.1. That will give you 1.5 megabits per second, which is exactly that. And remember that there's a formula that has not been written here that I'm telling you. The number of requests, unfortunately I do not have my pen here, but I'll just, the number of requests multiplied by the size of the object, my handwriting, gives you the average data rate to the browser, which is 1.5. And the average request rate from the browser, then this one is a variable one. It can be anything. But this one is basically dependent on the formula here. All right. All right. Okay, so now we want to calculate some performances, right? So we have the land utilization. In this instance, we will speak about percentages, right? And we have the end-to-end delay. Remember from our previous lectures that the delay is made up of a lot of things. And in this instance, we'll be having the internet delay, the access delay, and the land delay. The internet delay is basically the transfer, the internet delay and the access link delay, they are in the site, and the LAN delay, they are all within your network, your local access network. Right. How did we get to this 0.5 or 0.0015 and 0.97? Right. So what you do here, the LAN utilization, you can see it's very small. It's very, very small, 0.15 percent. How did it get calculated? Right. So what we do, we have the average. We basically have the average data rate to the browser, which is 100 and 1.5 megabit per seconds, right? If you are within the LAN, right, one like a communication within the LAN with this data rate to the browser. So what you do 1.5 divided by 1,000, because 1 gigabit per second, or 1 gigabits, it's basically 1,000. So what you would do, you do 1.5 divided by this, that will bring 0 to the 3. It will bring back the decimal point 3 positions to the left. So 1, 2, 3. And if you put 0 here, that makes basically 1, 2, 3. We have another 0 here. That makes 0.0015. That's the land utilization. And the land utilization 0.0015 makes it very small. So if you have this type of transaction of 0.1 megabit, if you have a 0.1 megabit object, within the lane here, it will be fairly quick to transmit it, right? And the formula is exactly what I've done here, which is the average data rate to the browser, right? We have the average data rate to the browser, right? Divided by the transmission rate, right? Divided by the transmission rate. That gives you the utilization. Now the access link, this guy, the access link utilization is the same thing, 1.5 divided by 1.54, because we said it's 1.54. And you can see that these two numbers are very close to each other, which means that the utilization is fairly big, right? For us to basically notice that, you can literally do the computation. You would see 0.97, right? So if I do that for you, it will be fairly quick. So 1.5, sorry. So 1.5 divided by 1.54, 1.5 divided by, okay, 1.5 divided by 1.57. That gives you, 1.54, 1.54, that gives you 0.94 and 97.4. We discount the 4 is less than 5. Then you see that we have a very big utilization, which is bad, right? It is very bad. It is a problem. It's too high. Means that when we'll be doing the transmission here, just for this specific object, we'll be using 97% of the whole link, which is not good. So what we do, right now, basically, let's assume that we go for a faster, like for a faster access link. What does that mean? It means that we say, okay, instead of this 1.5, 1.54 megabit access link, we change it for a bigger one, like, right? We change it to 1.154 megabit per second. So we increase it by 100. We multiply this thing by 100. And then it will reduce everything by 100, you see, and it'll also reduce the end-to-end time from some minutes to some microseconds. What is the problem? These internet or this networking equipment are very expensive. It is seriously expensive to do such a thing. It's possible, but then it's expensive. So what we can do, we can install basically a web cache, right? If we install a web cache, remember that what you need to have in mind, right? Keep in mind that we have a network here. This is a network, this is another network, and this is the link in between them. And if you remember our proxy explanation, some computer from this network wants to access a server here. So it will cross everything here. But what if we have a little proxy here that simulates the other server for the time being, right? So if you have a cache, somewhere here, what will be the performance issue here? What will be, how will it work, right? Okay, so it will be cheaper to just have that little server here, a server similar to that, that will satisfy the request of this client to a particular extent. Obviously, this proxy cannot satisfy the client on everything, right? It's just a proxy. It also makes a request by itself to the other servers. But then if they all make a request to a single website every day like Google, then this guy will have a Google web page, right? And if you want to go beyond that web page, then you will make your way to the other servers, but it will also keep track of all of that, right? The next slide will be mostly speaking about the utilization and the delays when we use such a tool. All right. So we have something called the hit rate, That's basically the request that the cache can satisfy over the request that that cannot satisfy by. It's like when it has to go to the origin server outside. We call it the hit rate. In this case, we have 0.4, 0.4, which means that if a computer here wants to have something from this other server, this web cache will satisfy 40% of the request of what that local computer will do. And for instance, google.com, it will provide you google.com. But then if you type a new request like, give me the solution to all the assignments, obviously this guy doesn't have it. And for 60% of the time, he will not have it. But then for 40% of the time, he will go and get it. And when it does have some previous request, then it will give you everything that you require. Now let's go to the calculations. The access link utilization is 60% of the time. Remember, because 40% for the 40%, the web cache or the proxy server has access to it. And remember that the transactions are coming here. So when you send your request here, if it doesn't know about that request, then it will send a request outside, right? If it doesn't know about that request, it send the request outside to the internet. And that is part of this 60% of the request, right? What does that mean? Remember that the average of the data to the set to the browser is the number of requests multiplied by the size of the object that we have. And now, since we do not have 100, we do not send 100% of that request up to the servers, then we multiply by the ratio that the proxy server actually outsources, which is 0.6 or 60%. That's exactly the data that goes over the link, right? That's literally that. And what's the utilization of the access link? You divide it now by 154 to have 0.58, which is different from 0.97 in percent. This is 58% of the utilization of the access link, which is way lower than 97% of the time, right? And then if you want to calculate the end-to-end delays, then you have to give the delay from the proxy server to the servers, which is 0.6 multiplied by the delay that we have with the internet, 2.01, as we mentioned earlier, and 0.4 multiplied by some milliseconds. Like it's like some like tens of milliseconds. It's within the network because the network internally here is incredibly fast. So we will not see anything close to 1.2 seconds, which is reasonable, which is accessible. And you can see that um, it's also very cheaper. It's like we didn't change anything. We just added this little server that is the price of, that could be the price of another server. So it's fairly easy to have such a thing. But then, before us going to the next topic, which is the conditional get, let's go to an example, right? We going to an example. This is the conditional get that we do. So I I went around and I used the Tracert web page. I mean the Tracert utility that gives me the trace route of a particular website. So I did tracer google.com, right? I wanted to get to google.com. And as you can see, what it does, this is my local IP address, right? I mean, all the IP address of my particular router. It can be different from it can be different from one to another router, but then you always end by 0, 1, right? And then it goes to some IP addresses, and then it'll go to the Internet Exchange Point, which is located in Johannesburg. This is Johannesburg Internet Exchange Point. And then it goes to some IP addresses that we will go and follow. So it says that Google is this, right? Google.com. And we know that Google is somewhere located in the US. So what I'll do, I would um, basically look up this IP address here from this website. And Google, yes, is basically located somewhere uh, in Johannesburg. Aha, you see? So we want to access Google, right? This particular Google web page. But then where does it fall to? In the city of Johannesburg, right? And it's somewhere around here. You see that it didn't go all the way to the United States to get Google, right? It came back to Johannesburg. And even if, and you will see, for instance, that my internet service provider is a company called Cool Ideas. I wouldn't want to do advertisement here, but it's called Cool Ideas. And remember from the earlier the earlier slides saying that the the cache will be typically installed by the internet service provider, right? So now let's check that. Let's look at this. Look at the IP address just before it hits the that Johannesburg part. Okay, so you see it goes to Canada, somewhere in Canada. We don't care about that part in Canada. And I'm sure it's also a proxy address. It's like making me think that it's somewhere in Canada, but I'm sure it's not. And if we, okay, this one looks very foreign. Let's look this one up. Yeah, it goes to the US. And let's take this one. Let's go to this guy. All right. So you see that here we the website is going through multiple hoops and all of those stuff to go and get the page here. Yes, and you see that it went to the United States when I went. It went to the United States and then it went to Canada. We all remember that, right? Because if I check this IP address here, it it goes straight where? Okay, it goes to Pretoria or to, let's see, one or two. Let's check that again. Okay, you see, because I already made the request in front of before your eyes, I already made the request and then it just changed because remember the IP address was going straight to Canada, but then it's now being changed to Cool Ideas in Pretoria, somewhere in Pretoria, Cool Ideas. So you see that depending on where you are and depending on what you request, because if you make a request more than once to a website, your request will go through a cache, right? And because it already went through the cache with that request, then the cache will not make the request again. The cache will say, okay, cool. You know what? First of all, you are closer to me, and you made that request once, and I'll just give it to you. And this is my internet service provider, Cool Ideas, and they basically simulating Google, right? And this, if I now, what I've done, I'm pinging. Ping is also another networking tool that tries to check if a website is live. So what I'll do, I'll also query or look up, and this one is still Google, eh? It's still Google. So it's an address owned by Google, located in the city of Johannesburg again, right? It's located in the city of Johannesburg. You see, we do not actually leave Johannesburg. We're still in Johannesburg, right? So we do not travel too far. This is an IP address owned by Google, right? But then if I type there google.com, it will go straight to my Cool Ideas to get that page instead of going somewhere in the States. Now, what I've done the same thing for Bing. And I made the first, like when you do ping, and a website next to it, it gives you the IP address of that particular website. So it basically resolves the IP address of the website. And let's do that. That was the first time today that I was dealing with Bing with this computer. And where did the request go? The request went to New York in the United States, straight to Microsoft because Bing is a Microsoft product, right? So it went straight to the US, right? But then now when I pinged, like you see, I'm pinging Bing, and then it gives me the same IP address, right? And if we go back, we basically ping it again. We say, okay, you know what? You're looking for this particular IP address. That IP address is located in the United States. Now, when I do another, what I've done, I went to Bing, like so what I've done, I did www.bing.com, and you would see it's fairly quicker. It's very quick, right? And what happened is that it changed the IP address. It changed basically the IP address of the website. You see, it almost looked like Google now. And I use pink Bing here. It now gives me something like this. And guess where it went to? I'm sure you all guessed it. It's somewhere located in Johannesburg. Cool ideas, right? It's in Johannesburg, cool ideas. And then it's because I made the request already to Bing, and Bing is too far. And the guy already has a copy of it, right? And he will tell me, okay, cool. You know what? I'll send you what I have so far about Bing. And this is it. This is basically what you were looking for, right? And that's basically what I wanted to show you about the proxy servers and all those stuff. And feel free to try it out. It's a very interesting bit. It's very nice. All right, now we have the conditional gate. It's like a normal gate. What you do, you basically send your request to the server, and if the object is not modified, then it will send you the same object that it was having in the cache, right, since forever, but it will tell you that the last time it was modified, right? And if it gets modified yesterday or today or something, then it will send you a better version of your request. That's the conditional get. And you see, it will say the website's not modified, and it's it will be up to you or to your browser to always interact with the server to know exactly when the data was modified. And at the end of the day, because all of this is a whole request, remember assignments with with the screenshots. I know it was a bit complicated. Some people got lost in the process, but then you see that we have a request. Let me get the laser one. So we have a request here, right? And after all of that discussion between the server and the client, we have a response plus the data, plus the header, plus the protocol, plus the basically keep alive or not. We have our request, we have our response. Now we go to the sort of HTTP that's mostly for your personal knowledge. We mostly using HTTP 1.1. There's HTTP 2, and they are now building HTTP 3. But then for your own personal response or for your own personal knowledge, you have to know HTTP 1 when you're sending multiple requests. Unfortunately, it's like first come first serve. So if the first object is too big, then the other object might die in the process, right? So HTTP2, we just want to delay the process. So if one object is too big, it's chunked, and if one object is too big, it's then chunked in pieces, and then it will be the pieces of the bigger object will be sent along with the other objects in the queue, and the remaining object of the big one will be then sent afterwards, right? So there won't be any too big or too small. Everybody will be sent equally, but then the biggest object will be then chunked into different sizes. So whatever is written here is what I was talking to you about, the transmission order of the requested object based on the client specified object priority. Object priority is not necessarily first come first serve. It uses another algorithm to send the object to the client. So what I was saying, well, like HTTP one, you have this big one, and then you have the other objects. So what it will do, it will send all the object first, and then the other objects. This is very inefficient. These guys can get lost in the nature, and we don't want that, right? It's like this, you see, they will wait and they can die. They can get bored. It's like, okay, no, we actually didn't want to send anything across. Then boom. And the client receives only one object, not the other ones. Not very efficient. But then with the HTTP2, right, we break the object into multiple different pieces, send object one and the object across, and send the rest of the object one. Like you see, if because we are having two object three, then we send that there, and you will see that the remaining object address object one, and you see that object two, three, and four just went across. Object one, part of it went across, and the rest of the object one will also come after everything is done, right? And it's quicker. That's the goal. Now the HTTP3, we just want to decrease the delay when we send multiple objects, right? That's mostly what it does. It adds more security to the picture, and when we deal with UDP. That's the reason why UDP is still a thing in the market, and then it does interesting stuff. Other than not being able to do the handshake situation, but then it is very, very important, and I'm sure most of us will go more towards UDP at the end of the day, right? So this is the end of lecture number 4. I really hope that you enjoyed it. I'll be going over lecture number 5. It's also divided into 3 different parts that I'm sure they'll be very interesting for you. As usual, we'll be having a quiz that we'll do, the normal quiz, not a very complicated and disturbing assignment where the requirements are changing. It will be just a quiz with normal questions and calculations about the lecture. I'll build another assignment for you so that you get again your hands dirty. We will be we'll be always and only submitting practicals through GitHub. You will always use GitHub. Moodle, it's for the marks and it's for you to keep your marks in the track, on track with the university, but then your assignments will be on GitHub. Thank you very much, guys, and enjoy the lecture again. Bye bye.